Good afternoon, everyone. Today we're going to solve a radical equation where we have radicals on both sides. So first things first, let's list our restrictions on the solutions that we might find. Our restrictions come from we can't evaluate the square root of negative values, and so we need the radicand, the stuff underneath the roots, to be not negative. So 5x minus 9 first needs to be greater than or equal to 0, and that means that x needs to be greater than or equal to 9 over 5. And we also need x plus 4 to be greater than or equal to 0, and so x needs to be greater than or equal to negative 4. Now, this one is embedded into this one, right? If any value of x is greater than or equal to 9 over 5, which is 1.8, then obviously it satisfies this inequality. And so we can just kind of embed our second one into the first one. Okay, so this is really our conditions on solutions for x. Okay, so now let's go ahead and solve this equation. Since we have radicals on both sides, we're going to have to square both sides. Let's make our life as easy as possible. Let's move one of the constant terms to group them on one side. So I'm suggesting we subtract 3 from both sides. And so we'll have the square root of 5x minus 9 being equal to, 3's are gone, the square root of x plus 4 plus 1, right? Now we can square both sides, and so we square the left and we square all of the right side. Again, when we square both sides, we square everything on both sides inside of brackets, not individually, not each term individually. The entire thing inside a bracket is squared. Now, this square root cancels out, and so we get 5x minus 9 is equal to, now we have to expand this out as a binomial squared, so we get root x plus 4 squared is x plus 4 plus 2 root x plus 4, and finally plus 1, because 1 squared is 1. Now, let's group this a little bit. So we'll have 5x minus 9 is equal to x plus 4 plus 1, x plus 5 plus 2 bracket, plus 2 rather, square root of x plus 4. And now already we went from 2 radicals in our equation down to just 1. So now that we have only 1 radical, let's isolate it. Let's get it all by itself on one side. So let's move this stuff, subtract x, subtract 5, subtract x, subtract 5, and so we get 4x minus 14, these cancel out, is equal to 2 square root of x plus 4. And now, once again, we've successfully isolated our only radical. Now let's square both sides again. And again, when we square both sides, we square everything on both sides, like so. So if we expand this out as a binomial squared, we get 16x squared. 4x times 14 is minus 56x. Twice, that'll be minus 112x. And negative 14 squared is plus 196. On the right-hand side, the square hits both parts because these are multiplied together. So 2 squared is 4, and the square root of x plus 4 squared is x plus 4, right? So now we are done with the radicals, and we have a quadratic equation. We're pretty good at solving those by now. So we have 16x squared minus 112x plus 196 multiply through equals 4x plus 16. And now, like we always do with quadratic equations, let's get everything on one side and set it equal to 0. And so, like so. So now we have 16x squared minus 116x plus 180 is equal to 0. And are we able, we can divide those by 4 to make our life easier. We can divide both sides by 4. And that means we get 4x squared minus 29x plus 45 is equal to 0. And my guess is that we can solve this by decomposition. So let's go ahead and do that over here. So we'll have 4x squared, we'll have plus 45. And now we have to consider what two numbers multiply to make 4 times 45. So what numbers multiply to make 180 and simultaneously add to make negative 29. You might take a moment to figure those out on your own. Pause the video if you want. Those numbers are negative 20 and negative 9. Negative 20, negative 9. And so let's decompose that middle term, right? Negative 29x. It's written in this new way. And now we'll factor the first two. And so we get 4x times x minus 5 minus 9 times x minus 5 once more. And so we get 4x minus 9 and x minus 5 is equal to 0, meaning in solving this equation, we get our solutions. X is 9 over 4 or x is equal to 5. Now, x is 9 over 4, that is 2.25, or x is positive 5. And I'll remind you that our restrictions were that x had to be greater than or equal to 9.5, to 9 over 5, which is 1.8. And so both of those possible solutions, they at least adhere to our restrictions. Our restrictions are not violated. And so we have to consider both of these. Now, when we are working with radical equations, we run the risk of running into extraneous solutions. And so we have to check both to see if they're real solutions or if they're extraneous. If they fall victim to the whole, the square root of a number can be positive or negative. I'll digress on that one. So let's verify both by plugging them back in very specifically to the original equation. It has to be in the original equation, right? So if x is 2.25, we'll have the square root of 5 times 2.25 minus 9 plus 3 is equal to the square root of 2.25 plus 4 plus 4 plus 4. That means the square root of 5 times 2.25, that's 11.25 minus 9 plus 3 is equal to the square root of 6.25 plus 4. That means the square root of 2.25 plus 3 is equal to the square root of 6.25 plus 4. That means that 1.5 plus 3 is equal to 2.5 plus 4. And that means that 4.5 is equal to 6.5. And of course, that is not true. Right? Did I do that right? I believe I did that right. Yeah. So this does not hold. So this is not a real solution. This is an extraneous solution. Okay? Now, the other possibility is that x is equal to 5. This will be a tiny bit easier to plug back into our original equation. So if x is 5, our equation becomes the square root of 5 times 5 minus 9 plus 3 is equal to the square root of 5 plus 4, right? Plugging that value back in. And so we have the square root of 25 minus 9 plus 3 is equal to the square root of 9 plus 4. That means the square root of 16 plus 3 is equal to 3 plus 4. That means that 4 plus 3 is equal to 3 plus 4. And of course, that absolutely is true. And so we get that x is equal to 5 is our one and only solution. And there we go. So we have to consider whether our possible solutions respect the restrictions that we have on our variables, on our unknowns. And also we have to check for extraneous solutions because we are dealing with square roots and square root of numbers. For example, the square root of 9 is positive or negative 3, and sometimes that can cause problems when we go back and verify. So I hope that helps. Thanks for watching.